This is crash on stake. You place a bet and a multiplier starts climbing, 1x, 2x, 5x or higher. Cash out before it crashes and you win your bet times that multiplier. Cash out at 2x, you double your money, at 10x you 10 times it. But if you wait too long and it crashes, you lose your bet entirely. There's no practical ceiling, it can crash at 1.00x instantly or fly past 1,000. 4 questions I'll answer. What are your real odds? Is there any strategy that beats the house? Can the casino rig the result? And can you prove it? I'll answer all 4 with maths. You can check yourself because the whole game is one number per round, decided before the round even starts. Let me show you how. Every round has a hash, shown in the game history. 3 steps turn it into the multiplier. This round crashed at 2.90x. I'll rebuild that number from scratch. Step 1. 2 inputs. First the round's hash, and it's not generated on the spot. It's locked in before the round, part of a sequence stake committed to ahead of time. So they can't swap it to change your result. More on that later. Second, a Bitcoin block hash, block 584,500. The same block for all 10 million rounds, committed before it was mined. Both go into the HMAC SHA-256, a keyed hash function. A key and a message in, a fixed string out. The round's hash is the key, the block is the message. Once both inputs are known, anyone gets the same output. That's what makes it checkable. HMAC alone doesn't stop an operator choosing inputs. The fairness comes from committing to the chain before that block hash was known. The output is a 64 character string, 32 bytes. Step 2, we only need the first 4 bytes. These 8 hex characters. Hex is base 16, and 4 bytes gives a number from 0 up to 2 to the 32 minus 1. Convert these 8 to base 10, you get 1,462,354,384. That's the 32-bit value behind that multiplier. Step 3, the formula. 2 to the 32 divided by the value plus 1 times 0.99, floored at 1. 2 to the 32 is the number of possible values, about 4.3 billion. So dividing it by our value gives a result almost always near 1 and occasionally huge. That's the crash curve. The plus 1 avoids dividing by 0, the floor keeps the minimum at 1x, and the 0.99 is the 1% house edge. When you run it, we get 2.9076, stake truncates to 2 decimals, always rounding down, so it shows 2.90, a live casino result reproduced from 2 public numbers and 1 formula. That formula also tells you your odds. To reach a target T, the multiplier has to get there before crashing, and the chance is about 0.99 over T. To reach 2x, it's a 49.5% chance. Reach 10x, a 9.9% chance. And to reach 100x, a 0.99% chance. And about 2% of all crash rounds end at 1.00 instantly. Now the expected value, target T, you win T times your bet with a probability of 0.99 over T. Multiply them and the T cancels. You're left with 0.99. Every target returns essentially 99%. Same edge at every multiplier. 1.5x or 1000x, both a 1% loss. The cash out point changes your variance, not your edge. And a martingale strategy, doubling after each loss, doesn't change it. A long enough losing streak hits the max bet or your bankroll, and the bet sizing doesn't touch the underlying return. No pattern turns a negative edge positive. There's a catch most players miss, and it depends on the bet size. Stake has 2 caps, the multiplier caps at 1 million X and the profit caps at 2.5 million USDT, whichever hits first. Since profit is winning minus stake, your bet sets your real ceiling. At 1 USDT, you can reach the full million X, at 100 it's 25,001X, at 1000 it's 2501X, at 10,000 USDT, the profit cap is reached at 251X. The bigger the bet, the lower your ceiling. The huge multipliers are only reachable at smaller stakes. So why can't stake just pick a number that wipes everyone out? This is what makes it provable. The hash from step 1 isn't generated when the round happens. It's one link in a chain stake committed to in 2019. They generated 10 million hashes in advance, each the SHA-256 of the previous hash's hex, then published the final hash on the Bitcoin Talk forum, before any game was played. along with the block they'd anchored to, block 584,500, which was not mined yet. Each hash in the chain is the SHA-256 of the one before it. So if I take this round's value and run SHA-256 on it, out comes the previous round's value exactly. And that proves the chain hasn't been touched. Swap in a different result and the links break. Change the multiplier on the screen without changing the underlying value, and it fails the formula. Either way, it's detectable. And because block 584,500 wasn't mined when stake committed, they couldn't have built the chain around it. One more thing, Crash is a multiplayer game. Everyone shares one round. So there's no client seed like a single player provably fair game, where your only input feeds the result. Block 584,500 fills that role. One public value stake couldn't set in their favour. So your crash point was fixed years ago, anchored to something unpredictable, and you can verify the whole chain yourself. And that's exactly what I did. Take round 8,246,854. This round's hash unrolls the entire chain. I ran this off screen for every game stake has run since 2019. Run it backward, and you derive every crash point before it. Here's all 8.2 million rounds stake has ever played. We take stake's formula, plug in that hash and the number of rounds, and re-derive all 8.2 million crash points. The highest ever, 2.17 million x. The lowest, 1.00x, which hit 1.97% of the time. The maths predicts 1.98%. Then the real RTP at every cash out target, 2x, 5x, 10x, 50x. Everyone lands on 99% within the expected margin. Cash out at 2x, 49.511% of the rounds get there. The theory says 49.5%. Finally, watch the real return as the rounds pile up. Early on it's noisy, but as the rounds climb into the millions, it tightens right onto the line. Across all 8.2 million, we get 99.087% against a theoretical of 99%, within the expected margin. Exactly what the math says for the last 7 years. So that's what provably fair means. The result is derived from the maths, and the house edge is built into the same maths, so no strategy can beat it. You can't beat the edge, but you can verify exactly what you're up against on every round, which is more than most casino games give you. If there's another game you want broken down like this, leave it in the comments.